So I'm given the function f of x equals x squared plus 8x plus 7, and I want to find the x and y intercepts. So starting first with my y-intercept, remember at the y-intercept, no matter the function, no matter what the equation looks like, at the y-intercept, my x value is always equal to 0. So I'm going to use that to find the y-intercept. So I have y equals x squared plus 8x plus 7. And I know at the y-intercept x equals 0, so I'm going to plug in 0 for x. So I have y equals 0 squared plus 8 times 0 plus 7. And I'll simplify. So I have y equals 0 squared is 0 plus 8 times 0 is 0 plus 7, which gives me y equals to 7. So I know my graph crosses the y-axis at 7, which is the point 0, 7. Okay. So to find my x-intercept, we know that at the x-intercept, the y value of that coordinate is 0. So at the x-intercept, y equals 0. And again, I'm going to use that to solve. So I have y equals x squared plus 8x plus 7. And to find the x-intercept, I know y equals 0, so I'm going to plug that in. So I have 0 equals x squared plus 8x plus 7. And just like we solved for y, for the y-intercept, I need to solve for x on the x-intercept. This is a quadratic. We've talked about 3 different ways to solve a quadratic. I can factor, I can do quadratic formula, or I can complete the square. All right, we're going to do solve this one by factoring, and we'll look at one in just a second, and we'll do quadratic formula, whichever way that you prefer to do it. All right, so this one, I know it's factorable, so I'm going to go ahead and factor it. I do not have a value in front of x squared. Well, I do. It's a 1, so I don't have to take into account that value, so I'm just looking at the last number, my 7. And I want to know, what do I multiply together that gives me 7? And it is just 1 times 7 because 7 is prime. 1 plus 7 gives me 8. So I know these are my factors. So I can rewrite the quadratic in factored form as 0 equals x plus 1 times x plus 7. Now, since I have it factored, I can break it apart into my 2 separate equations. So I have x plus 1 equals 0, and x plus 7 equals 0. To solve, I'll subtract 1 from both sides. So I get x equals negative 1, and subtract 7 from both sides. So I get x is equal to negative 7. So the parabola crosses the x-axis in 2 different places. It crosses when x is equal to negative 1 at the point negative 1, 0. And it crosses the x-axis when x is equal to negative 7 at the point negative 7, 0. Now, with this information, I can do a rough sketch of what that graph would look like. My x-axis, my y-axis. I know that my graph crosses the y-axis at 7. 1, 2, 3, 4, 5, 6, 7. So right here. And I know that the function, the parabola, crosses the x-axis at negative 1 and at negative 7. So 2, 3, 4, 5, 6, 7. Now I have these 3 points, and in order to make the parabola, I can connect them, but I need to know what this graph is going to look like. Is it going to be open upward or open downward? So the way that we can tell, if I come back looking at the standard form of my quadratic, the number in front of x squared, a, we call this our leading coefficient. If our leading coefficient, the number in front of x squared, if that value is positive, then my parabola will be open upward. So like the first graph that we drew, the one on the left, if a, my leading coefficient, is positive, then my graph will be open upward. If the leading coefficient, a, is negative, then my parabola will open downward. So like the right graph, it'll open upside down. Okay? All right, so going back to my example, I have x squared equals 8x plus 7. My leading coefficient, the value in front of x squared, it's not there, but it is. It's the understood 1. A equals 1. 1 is a positive number, so I know that this graph is going to open upward. So it's going to look something like this. All right. Now I call this a rough sketch because I don't know how far down to go. Right? That vertex could be just right here. It could be way down here. But I just did a rough sketch and just kind of guessed. In a few minutes, we'll look at how to actually find that value to make a more complete graph. All right. But for right now, those are our x and y intercepts, and that is the rough sketch of my graph. Okay. Let's do one more. All right, so I want to find the x and y intercepts of f of x equals negative 6x squared plus 14x minus 4. So I'm going to start off again first just by finding my y-intercept. And again, remember that x is equal to 0 at the y-intercept. So I have y equals negative 6x squared plus 14x minus 4. I know x is 0, so I'll plug that in to solve for y. So I have y equals negative 6 times 0 squared plus 14 times 0 minus 4. So y equals 0 squared is 0 times negative 6 is 0 plus 14 times 0 is 0 minus 4. 0 plus 0 minus 4 gives me negative 4. So I know that this parabola will cross the y-axis at negative 4, which is the point 0, comma, negative 4. All right, so now to find my x-intercept, or x-intercepts. Again, we know that y is equal to 0 at the x-intercept. So I have y equals negative 6x squared plus 14x minus 4. Y is 0, so I'll plug that in. 0 equals negative 6x squared plus 14x minus 4. Now again, I have a quadratic. I need to solve. I need to solve for x. So we can complete the square, we can try and factor, or we can do quadratic formula. Does this factor? I don't know. It might not. It actually does, but I do have a number in front of x squared, which makes it kind of right? So we can just bypass the whole factoring fiasco and just go to quadratic formula. If that's what you're more comfortable with, you can do quadratic formula on every single quadratic, right? Main thing, you need to memorize the formula. Google the song and sing it to yourself all day. Write it down 13 bajillion times until you are mumbling it in your sleep, okay? So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now notice this is x equals a number. A, b, and c are just numbers. There are no x's inside of my quadratic formula. Okay? Do not make it more complicated than it is. So I need to identify a, b, and c. Remember from our standard form, a is the number in front of x squared, b is the number in front of x, and c is the plain constant, right? The number all by itself. So I'm going to go through. Before I start plug and chug, I'm going to identify a, b, and c. A is the number in front of x squared, so a is negative 6. B is the number in front of x, so b is 14. And c is the number that's all by itself, so c is negative 4. So go ahead and plug in my values. I have x equals negative b. Anytime I see a negative inside of a formula, it just means the opposite. This means the opposite of b. B is positive. The opposite of b is negative 14. So if b had already been negative, the opposite would have just been a positive. So I have negative 14 plus or minus the square root of 14 squared minus 4 times a times c. All over, so the whole thing divided by 2 times a, which is negative 6. So there's my quadratic formula. Now I need to go about simplifying it. There's a lot of places here to make algebraic mistakes, so let's take it slow. I have x equals negative 14 plus or minus. I'm going to start on the inside of my square root and simplify that first. Right? The rest of it's fairly straightforward. But let's go through, let's figure out what I have underneath the square root and then simplify it so we can reduce. So I have the square root of 14 squared. If you're not sure what that is, go off to the side and multiply, but 14 squared is 196. Now, a big place that a lot of people make errors is whether this is going to be plus or minus afterwards. I have, forget everything else for a second, I have negative 4 times negative 6 times negative 4. What is a negative times a negative? Positive. Times a negative. Negative. So forget about the signs. I know when I multiply all this together, I'm going to have a negative. I'm going to have minus. Okay? And then a number. I know it's a minus sign. So 4 times 6 times 4. However you want to multiply that, 4 times 6 times 4 is 96. 96. All over 2 times negative 6 gives me negative 12. So I have x equals negative 14 plus or minus the square root of 196 minus 96. This one comes out fairly pretty. 196 minus 96 is 100. All over negative 12. The square root of 100 is 10. So now my x-intercepts, this plus or minus means I have my two solutions. So I'm going to break it apart into my two solutions. I have x equals negative 14 plus 10 over negative 12. So let's go ahead and simplify that. Negative 14 plus 10 gives me negative 4. So negative 4 over negative 12. Reduces negative over a negative. I know my answer should be positive. Negative divided by a negative is a positive. And 4 over 12 reduces to 1/3. So one of my x-intercepts is 1/3. The other x-intercept, I'm going to have x equals negative 14 minus 10 over negative 12. And I'm running out of room, so I'm going to squish it in here. Negative 14 minus 10 is negative 24. Negative 24 divided by negative 12. Negative divided by negative gives me a positive. 24 divided by 12 gives me 2. So I get x is equal to 2. How about, is it negative 2? Positive 2. Yeah. We good? Yeah? Did I do that right? I did. Okay. So I have my two x-intercepts and my y-intercept. So again, I can do a real rough sketch real quick. I know this graph crosses the y-axis at negative 4. And it crosses the x-axis at 1/3, so about right here, and at positive 2, so about right here. Is this parabola going to open upward or open downward? So if I go back and I look at my leading coefficient, the number in front of x squared is negative. So I know my parabola should open downward. So it's going to be upside down and upside down parabola. So something like that. Again, we have the issue, I don't know how high or how low to go for my vertex, but we're going to look at how to find that value to improve my graph.